All right, this is the first, and this for the next few days, you're gonna have small chunks of problems to do, and I'm probably just gonna do them all in one video. Maybe break up some of the ones later on this week. But for today's video, both problems 1 and 2 will just be included in this single video. We're gonna start doing mass to mass stoichiometry. We've done mass to moles and moles to mass. This is just more of the same, just a little bit longer. So, what we know so far is we know how to take moles, convert up to particles. We know how to take moles and convert down to mass using the molar mass. And we know how to convert from moles to another kind of substance using moles. So, for this first problem, we're looking at photosynthesis. And in photosynthesis, you've got 6 carbon dioxides combined with 6 waters to create glucose and 6 oxygens, 6 O2. You can see that on your page there for today's assignment. So, the first question you have is, if a plant needs to make 12.6 grams of glucose, how many grams of water are required? So, like in the last video, we're going to ask the same questions. I'm not going to write them this time. But our first question is always, what do we know? And so we know that we have 12.6 grams of glucose. Okay, so we know we have 12.6 grams of glucose, and we want to know how many grams of water are required to make that much glucose in photosynthesis. So how much water would a cell need? So how many grams of water do we need? So, like last time, we're going to separate this out. This side of our graphic organizer, let's assign that to glucose, C6H12O6. And let's assign water to the other side. So we know we have to convert from glucose to water at some point, and the only way we can get across this divide is by doing a moles to moles conversion, using a mole ratio. Well, we know we're starting off with 12.6 grams of glucose, and grams is a measure of mass, so this is where we're starting off, with mass of glucose. And we need the mass of water. So let's look over here. We've got water, and I don't have mass up there yet. Well, it turns out you can mirror this. We just haven't been writing it because we haven't been doing these long problems. But we can mirror it, so, because the same conversion going from moles to particles of glucose is very similar, and you know how to do it, just like you know how to do the conversion going from moles to particles of water. And you can also go from moles to mass of water using another molar mass. And so, if we're going from mass to mass, we can't just go from mass here to mass here. The only way we get across this dotted line that separates our substances, separates glucose from water, is to go up here to moles. So what we have to do is we have to start with grams of glucose, go up to moles of glucose, over to moles of water, and down to grams of water. And we see that taking that route to get to our answer, we need 1, 2, 3 arrows. That's 3 conversion factors. So, let's set up the problem. And let's talk through this a little bit more as we do so. I'm going to, for fun, erase the top part here. We're not dealing with particles, so to give me some more space, I'm just going to erase it. It's still there, we're just not using it right now. And we know we're starting off with 12.6 grams of glucose. So that's a place to start. So let's just go ahead and write what we know we're starting with. We always write it like this. And we need to figure out how many conversion factors we have. Well, we've already mapped out a route. We're going from mass of glucose to mass of water. And the only arrows that take us from here to here, we have to go up, over, and down. So we're going to have an arrow going up from mass to moles of glucose, an arrow going from moles of glucose to moles of water, and an arrow going from moles of water down to grams of water. So that's 3 arrows. That's actually going to be 3 conversion factors. So let's take this one step at a time. Let's take it 1 arrow at a time, 1 conversion factor at a time. Let's do our first arrow, going from mass to moles of glucose. We know how to do that. We know that mass, grams of glucose has to go on the bottom because we want those units to cancel out. And moles of glucose have to go on top. So that's where we're going to. So our first error is just taking us from mass to moles. And that's, we look at it, it's going from mass to moles, we just need the molar mass. So as a reminder, the molar mass, we got C6H12O6. That's 6 carbons, 12 hydrogens, and 6 oxygens. You have to look up each of these molar masses on the periodic table. So 6 times 12.01, 72.06. 12 times, you look up the number for hydrogen, 1.01 is 12.12. And 6 times the molar mass of oxygen is 16. So 16 times 6 is 6480, 96. 96. So we add them up now. It's 180.18. So that's the number that goes with grams. So we're going to put 180.18 with grams and 1 with moles. And you guys know how to do this. We've done many molar mass conversions where we convert from grams up to moles. So that's just one step. And we know how to do each of these one steps. It just looks intimidating when it's bunch of them. So we've taken our first step. We went from mass to moles of glucose. Let's go to our second conversion factor. The second arrow is going from moles of glucose to moles of water. So we know that moles of glucose has to go on the bottom so the units cancel out. And we need to go to moles of water, so moles of H2O go on top. To figure out what numbers go in the blanks, we have to look at our balanced chemical equation, which you can see probably better on your page than you can in the video. So we look for moles of glucose. Let's see, glucose is over here. It doesn't have a coefficient. That means the coefficient is 1. Remember, if there's no coefficient, it's implied to be 1. For moles of water, we need to look up the coefficient for water in the balanced chemical equation. We see that there's a 6 next to H2O. So that means we need to have a 6 next to moles of H2O. So now we have numbers in units for both the numerator and the denominator. That conversion factor's done. So we just set up a moles to moles problem. So that's the second step of this. The third step, our third conversion factor, we're going from moles to mass of water. So we look here, we have moles of water. Well, we want moles of water in the denominator to cancel out. We're going to mass of water. We want grams of water on top. And it looks like, once again, we're trying to go from grams to moles, or moles to grams, and that means we need the molar mass. So for the molar mass of water, we need 2 hydrogens and 1 oxygen. Each hydrogen is 1.01, so 2 times 1.01 is 2.02. Each oxygen is 16, so 1 times 16 is 18. 1 times 16 is 16, getting ahead here. And when you add them up together, you get 18.02. And that's the number that goes with grams. So we have 18.02 grams of water and 1 mole of water. Now let's see what cancels out. Maybe we can get a lot of these units out of the way so we can have a smaller thing to work with and put it all on one board. Let's see, grams of glucose and grams of glucose both cancel out. Moles of glucose and moles of glucose both cancel out. And moles of water both cancel out. And actually, if they're all canceling out like that, that means you've set up the problem correctly. The goal is to only have grams of water at the end. So let's put this all together and then put it into our calculators. We've got 12.6. That canceled out times 1, which is just itself. That canceled out. Times 6. Moles of water canceled out. Times 18.02. And we still have grams of H2O. In the denominator, we've got 180.18 times grams of glucose canceled out, times 1 would just be itself. Moles of glucose canceled out, times 1 would just be itself. Moles of water canceled out. So actually, that's all that goes in the denominator for this one. So let's plug into our calculators. Let's plug in those numbers. 12.6 times 6 times 18.02 divided by 180.18. So that is 12.6 times 6 times 18.02 divided by 1, 80.18. Gives us 7.56. grams of water. So it's just like the other problems we've been doing, it's just a little bit longer. If you break it down into 3 separate problems like we do, it'll make it go a lot smoother for you. The final step, of course, we still need to check our sig figs. We've got 3 sig figs up here, we've got 3 sig figs down there, we're actually good to go at the moment. So that is how the first problem was worked out. If you need to, you can pause it, but this right here is your answer for the first one. I recommend attempting the second one before looking at how I do it, or don't watch all the way through and pause it when you think you're ready to try it on your own. I'm going to go ahead and get the next one set up here. All right, so problem number 2. I had it open. Same chemical equation as last time. If a plant needs to consume 36 grams of water, how many grams of carbon dioxide will consume? So if it needs 36 grams of water, how many grams of carbon dioxide did it consume to get there? So let's go ahead and use our graphic organizer. We're going to put water on the left-hand side and carbon dioxide on the right-hand side. It doesn't matter which side you put them on, we're just going to do it like that here. So we're starting off with mass of water, and we're trying to get to mass of carbon dioxide. And just like last time, there's no conversion that takes you from mass of one substance to mass of another. Unfortunately, we have to convert up to moles and then use moles to go between substances, then back down to grams. So again, we're going from mass up to moles, over to moles, down to mass. And you see that we crossed 3 arrows to get there, so that's going to be a 3-step problem again. So let's set up the problem. We know that it's 3 steps. We know that our starting number is 36 grams of water. Let's see, if we start writing it out, things tend to fall into place a little bit for us. And we'll just put it like that. Okay. So our first conversion goes from mass of water to moles of water. We'll take this one step at a time. So we'll put grams of water on the bottom, because that's where we start at. Wherever we start, we put on the bottom. And we're going up to moles of water. Wherever we're going goes on top of the conversion factor. We see that it's a mass to moles conversion. At this point, you've seen many examples of me working out the molar mass. You can go back to another video and see me actually work out solving the molar mass of water. I'm not going to work it out this time. I'm just going to give you the answer. So it is 18.02 grams of water for every 1 mole of water. You can do that by looking at the periodic table, looking up hydrogen, looking up oxygen, getting the mass of 2 hydrogens and 1 oxygen. Once you have that, that sets up our first conversion factor. Our second conversion factor is the second arrow. It takes us from moles of water to moles of carbon dioxide. So we're going from moles of water, and we're going to moles of carbon dioxide. Now it's a moles to moles conversion, it's a mole ratio, we need to look up the coefficients. The coefficient on water is 6. The coefficient on carbon dioxide is also 6. So it's 6 goes on the bottom, 6 goes on top. That'll be really helpful later on. Our final conversion factor takes us from moles of carbon dioxide down to grams of carbon dioxide. So we start with moles of carbon dioxide, and we're going to grams of carbon dioxide. Again, you can look at a previous video where I work out this very same molar mass calculation. To find the molar mass, we need to look at the periodic table. We need the mass of 1 carbon and 2 oxygens. When you find that the molar mass is 44.01 grams in every 1 mole. So we've set up each of these 3 conversion factors, which is each of those 3 arrows in the graphic organizer. So let's see what cancels out. Well, grams of water cancel out with grams of water. We have moles and moles of water on top and the bottom, they cancel out. Moles of carbon dioxide and moles of carbon dioxide, they cancel out. Actually, we've been given one extra gift in here. 6 divided by 6 is 1, which means it cancels out. So we're cleaning it up, we're trying to see what cancels out so we can focus on containing this a bit, making it a little smaller for us to manage. So we have 36 grams of water canceled out, times 1 is still itself, moles of water canceled out, all of that canceled out, times, there we go, finally something, 44.01 grams of carbon dioxide. You see, by canceling all the stuff out, it gives us a smaller thing to work with at the end. So if we can recognize what needs to go away, what we don't have to worry about, it makes problems like this a lot easier. And the denominator, we've got 18.02. Now we've seen grams of water canceled out, all that canceled out, times 1 is just itself, that canceled out. So we set up this big problem, a lot of it canceled out, and this is actually all the math that we actually have to do. 36 times 44.01 divided by 18.02. And if you put that in your calculator, come on. Let's try that again. 36 times 44.01 divided by 18.02 is 87.92 grams of carbon dioxide. And finally, let's check our sig figs. We only have 2 sig figs up there. I've got 4 down here. That means we need to round to the first 1, 2 sig figs, which means we're rounding that 1's place. So our answer should be 88 grams of carbon dioxide. So that's how you do both of today's problems. And the problem set, I encourage you to still submit your answers so I can so I can tell who actually followed along and who didn't. Tomorrow you'll have more problems like this. I think it's tomorrow it is 3 problems, and Friday we have another 3 problems. Again, I'll have videos showing you how to work those as well. So I encourage you to start them on your own, but if you can't, always use these videos to help you. Again, I hope you all are safe and healthy, and I'll see you later in another video.